Good morning, everybody. Today is June 5th. It's my birthday. So, hope everyone's having a good Friday. This quick video is to show you how to do the activities in the tutorial for ASA, SAS, and SSS today. I'm going to preface this, guys, by your ability to actually do these triangle activities in GeoGebra is not crucial to you doing well on the mastery test. Okay, the goal of this tutorial is to understand how triangles are congruent via ASA, SAS, and SSS. The ability to use the GeoGebra program is not as key. So I want you to play around with it a little bit today, but just know, remember, tutorials practice. So if you can't get these diagrams to match up perfectly how the question is asking you, don't stress it. Just move on. Okay, the big thing to focus on is the practice questions within the tutorial. The multiple choice, checking your answers, why is something right, why is something wrong. That's what you want to focus on. Okay, these activities with GeoGebra is just to help you deepen your understanding. All right, so I'm just going to briefly do this first one on slide 6, which talks about making a triangle and then trying to make another triangle that is the same size based on ASA. So the first thing it asks you to do is to create a triangle and figure out two angle measures and the side length between them. So when we go to GeoGebra, what I'm going to do is I'm just going to pick 3 points. Pick 1, 2, 3. All right, so notice that I always like to pick, when I make my triangles, either points that are going to have a completely horizontal side or points that have a completely vertical side. So like if I picked a point right there, right? Notice how this is a vertical line, this is a horizontal line. Okay, so always pick 2 points that at least make either a perfectly flat horizontal line or a vertical line. Next thing I do is I'm going to connect those with segments. So I'm going to click the line, go down to segment. I'm just going to connect all these guys. So A to C, C to B, B to A. Next thing I'm going to do is I'm going to find the length of side AB. Now I could count that by just doing 1, 2, 3, 4, 5, but you also have the tool right here where it says distance or length, and if I click from A to B, it tells me that AB is 5. So that's the first thing. Now, since we're doing ASA, we need the two angles that are sandwiching that side. So in this case, that would be angle A and angle B. So here's how we find the measure of A and B. I'm going to go back to this measuring tool and I click on this one right here. So notice if I hover over angle, it says select 3 points or 2 lines. So I'm going to select this. I'm going to click B, then I'm going to click A, then I'm going to click C. So see how that green's popping up and it's kind of following my mouse? So as soon as I go up, I can go past it if I want to get a bigger measure, but I'm going to go BAC. So that tells me that angle A is 56.31 degrees. All right. Now I'm going to do the same thing to find angle B. So I have to pick a starting point, my vertex, and then out. Now I have noticed that this problem happens. Like for some reason it's giving me the angle measure on the outside and not the inside. So if that happens, guys, instead change where you're starting from. So instead of going A to B to C, let's try C to B to A. There we go. So that's a 45-degree angle. So that is a triangle that reads as ASA. We know angle, side, angle. The side is sandwiched between, it's included between the two angles. All right. Now, for this one, then you'll record that information. So I would type in one angle is 45, the other angle is, what was it, like 56.31. Okay, 45, 56.31, and then our side length of AB was 5. And then I would click angle A, I would type in this and this, all right? Now the next part is where this gets a little tricky. So they're asking us to create another triangle that is the exact same size as triangle ABC and has the same ASA. All right. So the first thing we want to start off doing is to create got a happy birthday text right there from my friend. Okay. We want to start out by creating the segment that's nice and horizontal here. All right. So I need to go back and I click my 2 points. So D, I know it's 5 units. 1, 2, 3, 4, 5. Boom. So, and let's go ahead and draw a lot segment in there. And then let's also find the measure of that segment just so we can kind of use it and show that it works. All right. Now, the next thing we need to do is we need to draw in this angle and this angle here. So this is where this program can get a little bit funky. So instead of using this tool, because we don't know where F is going to be up here, that's what we need to figure out. Where would point F be to match up with point C? So I'm going to use the angle with given size. So this is going to allow me to pick 2 points and then draw an angle from those 2 points. So if I hover over, it says select leg point, vertex, then enter size. Okay. So a leg point can be anywhere on my leg. So it could be here. I don't know why it's doing that. Oh, wow. There we go. So we don't want that. Okay. So here, I thought it was here to here. And then we want 56.31. So see how that point's way up there? Now, obviously, this point is not the same as this, but that's giving us this angle. So what I'm going to do is I'm going to draw in a segment and connect those 2 points for right now. Okay. Now, our other point of our triangle is going to be somewhere on this line. We don't know exactly where yet. So I'm going to do the same thing I did to get 56.31. Angle with a given size, okay, and then I'm going to type in 45. Now, I noticed that this was kind of clockwise. There we go. Now, that's the thing you have to pay attention to. Now, when I first did this, if I go from D to E, notice how it says counterclockwise. Counterclockwise would mean that this angle would be opening up down in this direction. But I want that angle to open up in this direction. So again, clockwise rotation, counterclockwise rotation. So I'm going to change it to a clockwise. And so now I have a 45-degree angle. So notice that 56.31 matches up here. 45 matches up here. So now I'm going to connect E to D with another segment. And now, where those 2 segments intersect, that's going to be the location of our new point, right there. So that means, guys, that this triangle ABC, is congruent to triangle DEF via ASA. Now, the rest of the activity asks you to map this triangle onto this one. So what I'm going to do is I'm going to create a polygon from this right here. Okay. And then remember we have our transformation functions. So if I want to translate by vector, so now you can see my polygon is shaded. So I should be able to drag this thing and it fits directly on top of that guy right there, which is cool, right? Like this triangle is the exact same size as that triangle right there, and we made it using constructions of this GeoGebra aspect. Now, if it was an SAS one, right, we'd want to construct a triangle first, okay, just whatever we want, any size we want. And then we'd have to figure out what that middle angle was and stuff like that. But again, it's kind of for you to play around with. If you need help with this, please let me know. I can always log in with you to if you really want to know how to do it, we can always hop on Google Meet and I can help you out. If you need to rewatch this, do that. But hopefully this helps out. Okay, and happy Friday.